In this video, we are going to look at the required stopping distance for a car. Now, our car is going to be going down a grade at a 3% slope. And here's the car going that way when suddenly I jump out in the way. Oh no! Oh, I'm scared. So it is moving at 55 miles per hour. And the question is, how much distance does it need before it can stop? So if you go to AASHTO, you're going to find that the stopping distance consists of two different parts. The first part is the perception time, so distance to stop is equal to the velocity of the car times the perception time plus the braking distance, which is SB. So AASHTO usually assumes that there's a 2-second braking time. So if you have 55 miles per hour, times 2.5 seconds. There's of course 60 minutes per second. I'm sorry, 60 seconds per minute. Seconds cancel out, 60 minutes per hour. And all of this all cancels out. Now we want to convert miles to feet, and there are 5,280 feet in a mile. So with that, we have everything canceled out except the feet and the seconds. So if I grab my calculator and work this out, 55 times 2.5 times 5280 divided by 60 squared is equal to 201 feet. I'm sorry, these seconds had canceled out. They canceled out here by this guy. I don't know how I managed to accomplish that. But anyway, so 201 feet, that is the perception time distance. So then you also have the braking distance, which if you go to AASHTO, you're going to get an equation for that. S sub B is equal to velocity squared divided by 2gf plus g. Velocity squared divided by 2gf plus g. Alright, velocity is easy, that's just the speed of the vehicle. 2 times gravity, that's easy. F is a little bit tricky. F is the friction factor, and there are going to be a number of ways to calculate this. Hopefully it's given. Sometimes you have to pull it from a table because it's going to change based on the condition of the tires, the type of the roadway, whether or not the roadway is wet. There are also some equations that can be used to calculate F, but for this problem we're going to assume that the road is wet and that it's asphalt, and since we're going 55 miles per hour, it's going to give us a friction factor of is equal to 0.31. So let's work this out. This is 55 miles per hour. Since that's squared, everything is squared. Miles squared, 55 squared, hour squared, times 2 times 32.2 feet per second squared. Out of space. Who needs units? Alright, I'm just going to have to write small. This is friction factor is 0.31. 0.31. And grade is also tricky. It's kind of like friction. It's a little bit tricky to get correct. First of all, it's not in percent. You could imagine that if this was 3, the grade would tremendously outweigh the friction. So this is going to be 0.0, whatever that slope you had been given is. In addition, you're going to have to worry about the sign of the grade. And the best way to worry about the sign is to think to yourself, now if we're going down a hill, then the grade is going to increase this value. And so if the grade is going to increase this value because you're going downhill, then you need this to be negative. And that's the way I like to think about this. So since that is our case, it's minus 0.03, like that. Of course, then you need to convert miles per hour to feet per second. You can go through this whole analysis that I did up here, but what is easier is to go to a table of unit conversions, and you find out that if you convert miles per hour, if you multiply it by 1.4667, 1.4667, then that's going to convert your miles per hour to feet per second. You're also going to need to square this because you've got miles per hour squared, feet per second squared. And that's going to get rid of this and replace it with feet per second, and I'm going to have to figure out how to keep more room on these slides. So I'm just going to put feet squared up here and seconds squared there, and it's just messy as could be. Sorry about that. But anyway, these seconds cancel out. And there's of course a dividing line, but I don't always put that there. I didn't include these units. That was feet per second squared. Anyway, that goes away. Everything goes away. And we try to multiply this out with our calculator. I find that if I don't write these things clearly, I will more frequently make calculated mistakes. But anyway, let's see if we can multiply this out. I got 55 squared times 1.4667 squared divided by 2 divided by 32.2 divided by parentheses 0.31 minus 0.03 close parentheses go, and that's 360, and 360 seems pretty reasonable for our problem statement. So 360. So now we were originally asked what was the total stopping distance. Well, that is of course 201 plus the 360, and I'm not going to write any of that out. That's going to be 561. So that should be the answer to the question, 561.